So we saw that the half-wave dipole is an omnidirectional antenna that radiates most preferentially in the XY plane here, and it's somewhat directional in the elevation plane. It's omnidirectional because it's non-directional in the azimuth plane. And we can increase the directivity of an omnidirectional antenna, and we can therefore give it higher gain. We can by stacking omnidirectional structures in a vertical fashion to retain the same omnidirectional pattern in the azimuth plane, but a more focused elevation plane beam, which then has a higher gain. This technique is called a collinear array, and so we just basically, by stacking wire elements on a circuit board, we can increase the gain by developing this collinear array. And remember, gain doesn't imply that the antenna is creating any sort of power. It just means that the same amount of power is radiated in a more focused direction. And often these are called omni antennas. And here we're showing a typical pattern for an omni antenna in figure A. The antenna shown here in this figure for omni was formed from an array of 3 dipoles, all oriented along the z-axis. And what I want you to notice in this picture is how it still looks like a bagel, but now it's a little flatter. But there's another consequence. There's a little bowl stuck in the top and the bottom here and here that wasn't present in the dipole. So the bagel forms the omnidirectional azimuth plane, which I'm showing here in figure B. If you were to slice through it, it still looks like a circle. And it has its main lobes in the elevation plane, just like the dipole does. The little bowls here on the top and the bottom form the side lobes, and they're shown in this elevation plane here. You can kind of see these little side lobes as they show up. And this the azimuth plane again is formed by slicing the 3D pattern through the XY plane right here. And as expected, the pattern is circular and it passes through the peak gain at all angles. Notice that the pattern in the orthogonal plane is directional here. So this one's directional. So since this is non-directional and this one is directional, again, this is an omnidirectional antenna. Here we see that the resulting gain for this omnidirectional stack is about 5.8 dBi, and it's got an elevation beam width indicated here of about 38 degrees. So you can see that that beam width is significantly more narrow than the dipole, and so it's easy to see how the energy radiated from this antenna is more focused, resulting in a higher gain with respect to the dipole antenna. As is somewhat typical of omnidirectional antennas, the elevation plane pattern shows these obvious side lobes. The side lobes in this principal plane pattern, they're formed by slicing through these bowls that are on top of the main lobes in the 3D pattern. These 2 lobes for this antenna are about 14 dB down from the peak of the main lobe. So the difference between here and here is about 14 dB. You'll notice that the azimuth plane pattern is still the same as the well-behaved circular pattern is in the dipole, but the elevation plane is much narrower, indicating that the power is radiated in a more direct way and therefore producing a higher gain, with the consequence that we do have these side lobes here, which may or may not be a bad thing. So anyway, that's one type of collinear array, which again, this was 3 dipoles stacked in the z-axis.